on. Connect to this one. There we go. All right. There it is. Let's keep it on here. Okay, I'll put it in projector mode for you. We can get rolling finally. All right, there we go. So we'll just go ahead and I'll just type in a rational for you. Okay, let's go y equals parentheses x plus 2 divided by x plus 1. So all rationals are going to have some sort of a curve here and here. Okay, so what we're interested in is what's happening as I go from left to right, and all of a sudden this curve starts and it falls. Okay, and it's going to continue to fall. All right, and if you kept going, it would eventually come over here on this side. All right, you think, what kind of a graph does that? And if we zoom out a whole bunch, okay, you think maybe that it's going to join up here at the top, but it really doesn't. Okay, what happens is that the graph just falls and falls and falls and continue to falls, and then starts way up here in infinity and then comes back down and around. Okay, so that's what a rational is going to look like. They're going to look something like this, and the cause of that is this x plus 1 down here. So if we look at this graph, we see that it's coming down. Let me zoom in just a little bit. All right, so you can see that right in here, okay, it's getting close to a number on the x axis, right? And that number is -1. If I'm trying to trace close to it, you can see that it's close to -1. It's -1.076. And if I keep going, it's going to keep going and keep going. I'm going to get close to -1. And on this side, all right, as I go from this side here, all right, I'm getting closer and closer to -1 also. Okay, so let me try this to even illustrate this just a little bit more. X equals -1. If I put that in there, a vertical line there, you can see that, yeah, it gets really close to that line, all right? But it's never, ever going to touch it, okay? It's never going to touch it. And that's coming from the bottom here, because we know if we have a 0 in the bottom of a fraction, what happens? Can you divide by 0? No, you can't divide by 0. So that's the problem, okay? And that's why we say that this rational function does not exist at -1, because you can't have a -1 in here for x. When you do, that gives us 0, and we can't divide by 0. Okay, so that's what these graphs are going to look like. They're always going to have something, typically on the bottom, that's going to cause a problem. All right, so let me get rid of this one and this, and let's come down and put in a different one. Y equals, let's just go with parentheses x minus 2 this time, divided by parentheses, well, I guess I don't need a parentheses in that case, x, let's go with a plus, oops, a minus 3 instead. All right, so we have that. So this time, again, see I have these curves, right? And it's falling, 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 rising, rising, rising. And this time, it's at 3, because 3 minus 3 gives you 0, so that's no good. So we can't have a 3 there. All right, if I come down here and I put x equals 3, there it is. Right? It's going to hug that line, it's going to hug that line, but it's never ever going to touch it across it. All right. So that is a rational and its graph. They're all going to look like that. Okay. Or some sort of thing like that. Okay. They do have different, some of them will look a little differently, but they're all going to have some sort of a loop there. So let me go back to this. And come on. There we go. So a rational graph. So we're going to look like this. So let's see, we're going to have this, and it falls like that. So it looks something like that. Okay? And this is a dotted line here. And this line is called an asymptote. And that's what the rational function is. We're going to say discontinuous So the rational function is discontinuous at that value. All right? So what does that mean? Well, there's two types of functions basically. There's continuous and discontinuous, and everything that you've done in any of your math classes up to this point most likely has been continuous, because a continuous function means that I can take my pen or pencil and I can trace it like that and never do anything other than just tracing it. A discontinuous function means that when I graph it, I have to lift up my pen or pencil to graph the rest of it. That's discontinuous. Okay, so this would be discontinuous. Now, I don't think they mention that very much in the book, but that's what's going on there. Okay, they're discontinuous. So for those of you moving on to your higher mathematics, you're going to come up with the words discontinuous and continuous are going to mention that kind of stuff. All right. So this is a discontinuous function because I got to lift up my pen or pencil to trace it. Everything you've probably done up to now, all the little parabolas and lines, have all been continuous because I could just do it like that. All right. So the asymptote, getting back to that, that's where the function is discontinuous at. Okay, does not exist, that kind of thing. So the hope would be, I always say this, the hope is that if I write one down here, like this, okay, and I say, okay, let's graph that. So then you should be able to, without even using Desmos, to say, well, I can tell from right here that we can't have x be equal to 2 because what will happen if we add x as 2 on the bottom of that rational? What are we going to get? 0. Can't have 0 down there. Doesn't exist. All right, so then you would automatically have some sort of an asymptote there. All right, and then we could sketch it from here. Okay. All right, and that's a terrible sketch, but anyway, it looks something like that. Okay, so that would be the hope. You know, maybe by the end of the day, maybe by the end of next week or at some point, it'd be good if you can get to that point. You look at it and say, going to have a vertical asymptote there too. It's discontinuous. That's what I know. Okay. Now here's one. Where's the asymptote going to be on this one?
0.
Yep, it's going to be right at 0. Okay. So if you graph this in Desmos now, you know, it doesn't draw the asymptotes. By the way, some graphing calculators do. Okay. They will graph them. So it looks a little weird. Let's see, this is going to look like x minus 1, so it's going to cross. This one I think looks more like this. Good. Okay, here's a different one. All right, where's the asymptote of this one going to be at? Where? Well, I got a couple different answers. I got a -2 and a 2. What's going to make this 0? 2 is, because 2 minus 2 is 0. Okay. Oops. All right. Top part I'm not too concerned about right now. So that's where the asymptotes are going to be. Now, the other thing they're going to ask you in this section is, if that's where the asymptotes are, what is the domain going to look like? Okay. Well, remember that domain is the input values. Okay. So those are the things that we're putting into these functions. Okay. And pretty much everything that we've done has always been all real numbers. We've got a couple of things where there's been some exceptions to that, but for the most part, it's always been we can put anything we want in there. All right. How did that? Oh, see now, let's pop back to this thing. I'm just going to minimize that. So anyway, in this case, though, the domain is all real numbers except for what number? 2. All right. So then we would just say that x cannot equal 2. But everything else is okay. But boy, we have a real problem at 2 because you can't have a 0 down there. So you're under this section, which is 4.1. All right, they're going to ask you a couple things. They're going to say, where are the asymptote and what's the domain? Okay, let's see. I'm going to check. I think that's all they're going to ask you on asymptotes and domain. But I think I'll mention this anyway. Okay, so just so I have it covered, we got vertical asymptotes kind of figured out, right? But let's look at this also from a different point of view here a little bit. So I'm going to have to take this out. And let me go in back into this. Good. All right, I'm going to get rid of all of these because I don't want them anymore. All right, there we go. Okay. Now let's go back to this. Let's put in this one here. Let's go x minus 1, okay, divided by x minus 2. Okay. All right. Where's my vertical asymptote? This asymptote going to be 2. All right, great. See, we're figuring it out already. That's awesome. So, there's also another type of asymptote, right? And that one is if we take this and we zoom out to here, we see that this graph flattens out. All right, and if I put, if I push my finger on there, okay, I'm using the mouse, I can see the y value is getting close to 1, okay, from either side. Okay, so it's getting close to 1. So that asymptote is called a horizontal asymptote. Okay, so this graph, if I put in y equals 1, all right, that graph, it looks like it's right on top of it, but essentially it's really close to it, but just never touches it. See, there's just a little bit of space in there. Okay, it looks like it's going to be right on top of it if you zoom out, but in reality it's not. All right, it just gets real close to it. Okay, so that's a horizontal asymptote. Now, some rationals will not have horizontal asymptotes, and some do. Okay, it kind of depends. Anytime you see this flattening out, those are horizontal asymptotes. Okay, so let's try this. Try another one. Y equals, let's go with x plus 1 and x minus 2. And now I'll divide this one by x plus 3. I'm just making stuff up. So here, this one doesn't have a horizontal asymptote because it's not flattening out. All right, so this is an example when it doesn't have one. Okay, this actually has what we call a slant asymptote, but I don't think you have to worry about that. Okay, so vertical asymptotes, horizontal asymptotes. Okay. So if we have one that's like this, vertical asymptote, x equals 2, okay, bottom, horizontal asymptote, y equals 1. So those are the two asymptotes that exist, and the ones that you're going to have to know how to do. Okay, there's no slants in there. They should all be horizontal if they ask you. I'm not even sure they're asking you. Are they asking you for horizontal? If you look on what page is that first assignment on there? I didn't see anything on there that asked about. I guess if I had my book, I'd be able. I'm looking at the picture I took, but I just don't see anything about horizontals. I thought I saw them last night, though, when I was looking, but I just don't see anything there. Okay. They do ask you to evaluate, and you probably already know how to do this, but I'll toss it in there anyway. And they give you this function notation. They talk about horizontal.
Page 286.
286? Which 53? Oh, they have. Oh, they're just happy to solve that one, though, right? They're not asking you about it. Okay. Yeah, we'll do a couple. I'll show you some solving ones, I guess. But okay. So evaluate then. If it's like, say, you want to evaluate this at 1, right? And this isn't any different than what we've done before. So we just got to put this 1 in for that x. So the notation, the proper wise, will look like that. 1 plus 2, 3 over 3, and that's 1. Okay, so if they ask you to evaluate it, you're just going to put in the number in for x and just, go to work on it. Okay? And it really doesn't matter there's an x on the top or the bottom. We're just going to put that in there. There. Okay. All right. So, yeah, when you evaluate it, you just stick in that x in it, and whatever value it gives you, stick in it for x and do it. Figure out what it is. All right. Now, I did see they had some solved ones on here, which is kind of interesting, because they really don't do much solving till that's actually 4.4. But we'll do some of those anyway. That's the ones, I think that is like 50, 58 and 60 and those ones, right? I'm kind of surprised that they gave you some of those. Well, let's do a couple of those. Let me double check here. It's a little. Look at your yeah, those guys. Okay. So we'll do a couple of those. So something like that. All right, so if we're going to solve those, and again, they do more of your solving comes up in the 4.4. All right, but in this case, we'd have this. All right, the easiest thing I think to do is just make this over 1 and cross multiply. All right, that's what I think is easiest. So now if I cross multiplied, I'm just going to get 3 equals 5 times x plus 2. Okay, and then just work it out. Shove that 10 over there and boom, be done. And you can leave it as a fraction or a decimal. It doesn't really make any difference. Okay. So when you're doing some of those, I would just take and cross multiply them, all right, and go from there. All right, looks like you got some with x's on top too, so let's do some of those. So we're covering all our bases here. Okay, again, I'm just going to cross multiply. And just work it out. Boy, that's nasty. I came up with a good one this time. There we go. I think I've got everything covered. I think I do. So that looks like that's all of 4.1. Do you have any questions about anything? Vertical asymptotes, okay? The evaluating and a little bit of solving stuff on there. Anything you're not too sure about, make sure you ask, right? Okay. That's 4.1. We'll go a little bit more here and I'll give you a little break. So let's take a look at 4.2. All right. So 4.2 talks about operations on these things. So talks about multiplying them and dividing them. But before you can do any of that, we need to simplify them. So simplify rationals, and we're going to multiply and divide them. Those are our topics in this section. Okay, so rationals are like a fraction. Let's talk about a fraction for just a second. So, you want to reduce a fraction, right? 12 over 15 we reduce. We're trying to find the highest number that goes into both of those evenly, correct? That's what we're doing? Some see some people going, yeah. Okay. So if I take 3 into both of those, I get 5. That's reduced. So when we're doing a rational, it's not a whole lot different, except you're dealing with x's. So if we have, say, x to the 4th, and you did some of these in some of your prior math classes, over x to the 7th, we know that x to the 4th and x to the 7th, I can reduce that so that I get 1 over x to the 3rd. Because I have 4 x's here and 7 here, so 4 of them are going to reduce. Okay? Well, same thing happens here. If we have a 3x minus 3 over x minus 1, you could say, well, how does that reduce? Well, first of all, we got to take that top part, right, and we're going to factor that. So on all of the stuff that you're going to do from here on out on rationals, you're pretty much always going to factor them. Remember, that's what I was saying, that it's good to know how to do things by the guess method, because when you come up with some of those trinomials, you're going to be factoring them. So here, we can see that we can take that 3 out of there, and we're left with this. And now, there's my reduce. And I get 3. Alright, so the only difference, the concept is still the same, but we're dealing with variables now, and x's. Okay, so that makes it different. But the idea is still the same thing. So if we have, let's do another one kind of like that. So let's go with 2x minus 4 and x minus 2. Again, if I take the 2 out, I get this over x minus 2. That goes away, gives me 2. All right, so this is just simplifying. That's all we're doing. Factoring them and then simplifying. Factors, factors, what you do when you do these ones. A little tougher. We step the game up quite a bit here. All right. We got to factor though. So we're going to take the top part. Let's factor this. You should be good at this. So what do we get on the top? What are we going to have up there? A 2 and a 5. Good. Good. And a Positive 5. Remember, this is a minus, so then this 5 is going to take on that sign every time. Okay, here we got x plus 1 here. We have an x plus 5 there. That's the thing that's going to cancel. Nothing else does, but that's the one we're looking for. And there it is. So the idea, you know, going back to that 12, you don't have to factor anything because you can do it in your head so quickly. You go, well, yeah, 3 went into both of those. I knew that. So I don't have to factor it, write it out. Okay, but in this case, you do, unless you can see it right away. All right, what goes in there, but it's kind of hard. So, but the concept is still the same idea. All right, you're just finding that greatest common factor goes in there, and we can reduce it down. Okay, so this is simplifying. So let's see if we can find, see if I can find some harder ones here that I saw. Let's try one like this. Alright, so let's try one like this now. So now we've got stuff on the top that we got to factor, stuff on the bottom that we have to factor. So what is the top part going to look like? Right, x plus 2, x minus 2. Good. And what's the bottom going to look like? Hold on. What's it going to look like? So we're going to have x plus 2 and x plus 2. Good job. All right, so that's that. And then look what's going to go away. All right, x plus 2s are going to go away. Leaves us with this. Okay? Cool. So factor is the key here. Factor, factor, and factor. That's what I'm going to give you. Factor, factor, factor. That's what you got to do. All right? It doesn't matter whether we're simplifying or when we do some multiplications, divisions here. I'm going to give you a little break here in a couple of seconds. When we come back, we'll look at those. But we're still going to factor. Okay? That's what it's all about. Factor, factor, and factor. All right? Okay. So let's take a quick little break. We'll come back in about 5-10 minutes. I'm going to see if I can get my thing hooked up here, and we'll do some multiplication and division, and then we'll figure out what to do after that. Okay, let's do some multiplication. Okay, I guess it's done doing its thing. All right. Okay, so let's talk about thinking about multiplying rationals, all right, and what that would look like. So if we take a fraction, something like that, all right. So conceptually what we would do is probably do some sort of a reducing. So like this here, I could take a 2 and take a 2 out of there, and this I could go 3 and go like this, and I could even reduce this further. Okay, so when I multiply fractions, again, I'm going to take and reduce these all right. So the idea doesn't change just because we have variables. All right, we're still going to do that same thing. So if we have, I'm never going to forget my book again. All right. So if we have No, it's okay. You keep it. If I need to look, I'll look, Miles. Thanks. All right. So if we have something like this, what we want to do is reduce first. Okay, so obviously I can do this one. And I can do this. Okay, and I can reduce these x's. Okay, so this is an x and this is an x squared. So that's going to go, leave us with a 1 here. And now I just have to see what I got. Okay, so I have a 1 on the top because the 5's gone, the 4 is gone, the x is gone. And I have a 2 and a 2 and an x. So what we want to do is factor and reduce. Okay, so let's try some. So let's go with something like this over this. I'm picking one out of the book. Like this. Alright, so we got this kind of deal. So now we're going to factor, if we can, and reduce. Alright, so we're always looking to factor. Well, I can't factor the first one because it's just an x minus 2. There's nothing to do with that. I can't factor this one. Okay? Can't factor this one. The only one I got left is this one. I hope I can. Alright, I can take something out because that's the first thing I was saying, that when you factor, you always look to see if you can take something out. And we can. So that's going to look like 2x minus 2. And now, oh, hey, I can cancel these out. So I can cancel this out with this. And now it's just a matter of seeing what I have left over. Since that's canceled out on the top there, there's nothing there, so I just go x plus 1. So there's just a 1 there. Now I have 2x minus 1 on the bottom. Right? But I still have this remaining 2. That's going to pop out on the front. Now, a lot of people ask, well, do we do the bottom parts here? Do we do anything with those? No, you leave them. You actually don't want to multiply. You just leave it. Leave it in that factored form. Okay, you don't have to simplify it or multiply it. Okay, just leave it in factored form. And the reason for that is because if we ever have to figure out what the asymptotes are, we can just look at it. Whereas if we multiply it, it might be a little bit tougher for us to figure out what the asymptotes are. Okay, so let's try it now. Let's do some more here. Let's go with the x plus 3 and an x minus 1. And we're going to multiply. Alright, so let's go with one like this. Okay. Again, I want to look for things that I can factor. So x plus 3, x plus 1, I can't do anything with that. I can factor this one over here. And I can factor the one on the bottom. So now, once you have that, it's a matter of just figuring out, hey, what can I cancel out, right? So what can we cancel out? X plus 3 is going to go there. X plus 1 is going to go there. So what are we left with? Yeah, x plus 2 over x minus 3. So multiplying is more like just factoring and canceling things out than it is really multiplying. Yeah. Sure, what do you want me to do? Go up to here? Right, so we factored this to something else with a 2 out, right? Okay, and this x minus 2 and this x minus 2 is going to go away. Alright, this doesn't do anything, this doesn't do anything.
Okay.
And that 2, so this 2x minus 1 is here, and this 2 is a 9 in this. Tell me wrong. Okay, so let's try one like this. So now we have quite a bit of factoring to do here. Okay, back to the top part, what do we get? Bottom, nothing. Top part over on this one. Bottom one. Oh, did I mess this one up? Okay, here we go. And then this one. Okay. So, again, more factoring than anything else, but now once we get into that, we just start canceling things out. So what's going to cancel? X minus 2 is going to go away. X plus 1 is going to go away. And what else? X plus 4 is going to go away. So what's left? X plus 2. And that's it. Alright? So it's all about factoring. Okay? And just reducing it down. It's more factoring than anything else. Alright? That's why when we were doing it, I said, hey, you got to get good at it. Right? Now you see, look at all the factoring you did. You needed what? 3 factoring problems right there? Okay? And so that's why we want to be pretty good at it. So we did some multiplications. I think I covered a lot of multiplications there. But we didn't do divisions yet. And I did some harder ones, I think that. Let's see here. Okay. All right, let's do some divisions. So let's go x squared. Bless you. Divided by. All right, so here's a division problem. Now, with divisions and fractions, all right, let me go over here to the side real quick. What's our rule for dividing fractions? Oh, come on. Flip and multiply, right? Sure. So that's what we're going to do here. Before we even factor anything, we're going to flip and multiply. So I'm going to flip that. In fact, I would flip them. So when you're doing these, okay, you actually would flip them when you write it down. Okay, so if this is my problem here, right, I'm going to write it on paper. I'm just going to automatically flip it. Automatically. Just flip it. Okay, and now factor. Okay, so let's see, what can we factor here? What about this top one here? What does that factor to? X plus 2, X minus 2. Okay, can't do anything with this bottom one. Can't do anything with this top one. What about this bottom one down here? What do we got? Okay, what's going to cancel? Can we cancel this one and this one? No. Can't. Okay. Right. Same with the bottom. So we can only cancel, right, an X sort of on a cross like this and this. Okay. We can't go this way either. It's either going to be top and bottom, bottom, top, but not top, top, or bottom, bottom. Let's see, we have X minus 2, right? That's this one. We have another X minus 2, which you can put a square there if you want, but it doesn't matter. You know, you can write it out. They'll probably put a 2 there if you look in the back of the book. And then what about the bottom? Same thing. Okay. So I'm betting that if you go into the back of the book, you know, with a problem like this, they probably go like this, and they probably go like this. Okay. But on a test or quiz or something, I don't care which way you do it. Now I'm more interested in using factor to get the answer right. Okay. So with divisions, you're just going to flip and multiply. Okay. That's the key there, and then it's just more factoring. All right. That's all it is. Okay, let's try this one. Alright, so now we have this. Okay, so I'm looking right, this is a 98 by the way. So what I want to do with this is go ahead and flip it right away. So when I write it down on paper, I am flipping this. So finally we get one that's a little bit harder to factor, right? So here's where you have 4 AC problems if you did it this way. And that's just part of this problem. So that's why I said, man, maybe we better work on the guess method. So let's see how we do. Okay, what about this top one? What's that going to look like? So we have a 2x and a 2x, right? The only choices are 1 and 1. So this one's not too bad. So where's the plus going to go? We need a plus 1x. So we need a plus here and a minus here because 2 times 1, okay? 2 times 1 gives me a plus 2 minus 1, so that's what I want. Okay, so I want the 1 to be here. So when I multiply, that's going to give me a plus 2x. Alright, a little tougher on the bottom. I got a small number though, maybe I should try 3 and 2. I don't know, what do you think? What should we try? Let's try 3 and 2. See if it works. I don't have many choices here. Alright, let's see. So, I got 3 there, I got 4 there. I'm going to subtract them. I got it. Right? Because I need a 1x. Okay? I just guessed. Really just guessed. So, this was a 1. So instead of putting the 6 and a 1 here, I thought I'm going to go 2 and 3 because they're closer together. Maybe I'll get a small number. I only have one choice here, 2 and 1. So I'm just going to go. So we're going to go 3 times that gives me 3. 2 times here gives me 4. I subtract. I'm looking for a plus. So where's my minus and plus going to go? Plus is going to go where? The plus is going to go between the 3 and the 2 or the 2 and the 1. Think about what we need. So where's the plus? 3 and the 2. Minus is going to go there. Right? And again, the 2 is larger than the 1, right? I got to be careful when it's like in this form, but still that might work a lot of the time. So here we go. Now we got this one. Oh my goodness. We have lots of options here. I'm still thinking though I'm going to go 2 and 3. And maybe I'll go 2 and 3. But I'll flip them. See what happens. So I get 4 there. I get 9 there. Okay, even though 13 is a little bigger number, I got a 6 and a 6 here, you know, so if I'm putting 6s in 1, I'm going to get at somewhere I'm going to get a big number. Alright? So that's why I think I'm going to go with 2 and 3. Okay? And it's all positive, so we don't have to worry about signs. Okay, now we got the bottom one. This one I don't have any choice. This one I don't have any choice. It's just I need a 1 and a 3, or I need 1 and a 3, but I need to get a 5. So where's the 3 and the 1 going to go? The 3 is going to go with the 2, so it's going to look like that. And then the 1 here, let's see if she's right. So we got a 3 here. We got a 2 there. Yep, sure enough, that gives me 5. Good deal. Everything's positive. Plus, plus. Okay. Finally, all right, this is why this is problem number 98 or something like that. Okay. All right, so finally, we got it done, and we're ready to start canceling stuff. So what's going to cancel? Everything. Let's see, what have I got? Anything goes, oh yeah, 2x minus 1, that's gone. 3x plus 2, that's gone. X plus 1, that's gone. And those are gone. So what are we left with? 1. All that work, and all we get is a 1. Okay? Crazy. All canceled out. I would never be able to make that problem up. Yeah. Why 1? Because everything is canceled out. Alright? So, think about this. Yep, good question though. Because you might have thought it was going to be 0, huh? A lot of people thought it would be 0. But it's going. Everything cancels out. Questions on multiplication or division. It's a lot of factoring. I think I got everything that was in there. How I got rid of the 13? Okay, so we're factoring this by using what I call the guess method, so kind of guessing the factors. Okay, so and I could have put 6 and 1 here, right? So I just chose 2 and 3. Okay, and I guessed here 2, 3, and 2. But you know, after 30-some years of doing something, you can guess it pretty good, right? So anyway, if I go 2 times 2. That gives me 4, all right? And then 3 times 3 gives me 9. And I'm adding those to get to 13. Okay? But, you know, I think the rule of thumb is, Charlie, if you're looking for a small number, you're going to probably stay away from 6s and 1s. Right? Yeah. Okay. Good questions. Any others? Keep them coming. So let's see. Now we would have addition and subtraction. So let's try some additions and subtractions, see how that works out. Okay? And see exactly where we go. I just get concerned about throwing too much at you. This is a little bit crazy stuff. And then I'm going to give you some chance to work on some problems, and we can see where we're at after that. Okay. So addition and subtraction. All right. Still doing rationals. I always start out, let's talk about this. That's straightforward. Because when we add fractions, right, what do we have to add fractions? What's the key? Got to have common denominators, right? All right? And when we add them, do we add the bottoms ever? Nope. Just adding the tops, okay? If we don't have a common denominator, then we got to find it. So what would we multiply this fraction over here? What are we going to multiply this fraction by to get a common denominator? And what are we going to multiply this one by? Okay. So see, you're really good at this. The good thing is that it doesn't change when we put variables in there. All right? We're going to get the same thing. Okay, so our common denominator is going to be 30, and I'm going to add the tops. I don't do anything to the bottoms, and I get that. All right? So that concept is the same thing we're going to use when we're adding these guys. All right? Doesn't make any difference. Okay, so if I have a 2 over x, all right, and a plus 3 over x minus 1, okay, and I want to add these, I got to have a common denominator, because it would be nice, man, and it would be so nice if we could just go minus 1, minus 1. They can't do that. Okay? That changes the fraction. So if you have a 5 over 7, right, and you subtract 1, that's 4 over 6. Those are two totally different fractions. They're not the same number. Right? 4 over 6 is 2/3, and that's not 2/3. So you can't do that. Right? So you have to take this side, right, and multiply it by this x minus 1. And sometimes you'll hear me say, well, multiply this side by what's over here, because this guy, he has an x minus 1, so that's what I'm going to multiply by. Okay, same thing here. Well, I got an x here, but I need one over on this side, so I got to multiply by an x. Even though you'll say, but there's an x minus 1 there. Okay, but that's not, it's a term, all right? So you can't just add a 1 or subtract a 1 and call it good. All right, you just have to multiply it by whatever that term is over there. So now, finally, we got a common denominator. So a lot of times I'll just go like this and say, well, there it is. All right? I'm not going to multiply the bottoms because I don't, but I will multiply the tops. So I'm going to go like this, go like this, go like this. Okay, and then I need to simplify the top part. Bottoms, I'm done. Done with those. So let's see, we got a 3 and a 2 gives me 5x minus 2, and I'm done. On rare occasions, there are chances where you'll have to reduce that. Okay, it happens, they come up, but in this case, obviously, there's nothing we can do with it, so we can't factor or anything. So we're done. And again, the idea is we want to find common denominators. And it's always just safer to just pick whatever on the bottom here, multiply whatever's on the bottom here, and multiply just like we did with this one. Right? It's just not any different. The concept is still the same. All right, so let's see. Now we make, stepping it up a little bit. All right, so now we got something like this. All right, we're going to add. So what are we going to multiply this fraction by? What's over on the other side? X plus 1. Good job. Okay, so we got that there, got that there. Okay, what are we going to multiply this fraction by? What's over on the left side? X minus 1, awesome, we're figuring it out. Okay, all right, I know what's on my bottom now. I don't mess with it, leave it. Okay, let's work on the top. What are we going to get on the top over here? 3x plus 3, and just distributing. Okay, that's all we're doing, just distributing. Plus, what about over on this side? X squared minus x. Okay, simplify. Bottom is done. Don't worry about it. What are we going to get on the top? I know I got an x squared plus 2x plus 3. Okay. Well, I don't know. Let's see if we factor. Can we get factors of 3 or give us a 2? That's a good question. No, so we're lucked out. All right, we're done. So these ones are going to be, you know, like the multiplication division, we factored. Not so much here, a little bit, but not so much. Okay, you're probably not going to like this one, but I'll show it to you anyway here. All right. Okay. Now I'll probably see a few of these on that. This one, you'd say, well, you told me I should multiply the left side by what? What would we multiply this side by if we were going by everything I told you so far? And what would we multiply this side by? Okay, here's the problem. We can do that, but this thing here is almost the same as that one. It's just that instead of having a negative 2 and a positive x, what do we have over on the right side? Right. So here's what we're going to do. We're going to leave this one the same, and we're going to take a negative 1 out of each of those. Okay? So, what does that do for us? Well, it helps us a bunch. Because if I change this around, so it looks like this, but then I take a negative 1 out, I'm kind of stepping through this, so that now I have an x minus 2, but I have a negative 1 that I took out of the bottom, so I have to put it on the top to compensate for that. And that is completely legal, because if you have a 5 over negative 7, right, that's the same as negative 5 over 7. You're not changing the value of the fraction. Right? It doesn't matter 5 divided by negative 7 or negative 5 divided by 7. You're still going to get a negative number. So that's a legal thing. We can do that. Well, now this becomes way easier, because what are we going to get for an answer? Exactly. All right? So when you see something like this, and you're going to see them, okay? Yeah, we could have got the answer by multiplying by x minus 2, or 2 minus x and x minus 2, but guaranteed you would have had to reduce it at the end. You probably wouldn't have seen it. Best thing to do is say, hey, these two are, all I got to do is flip them, take that negative out of there, right? Throw it on the top, and combine them. Okay? That is really crucial thing to see that. Okay? So you'll see some of those. Yeah? Is there a rule? It's a trick. How about that? It's a trick, yeah. The rule is that it doesn't matter whether the negative is here or here. Okay, that's a rule, but we're using that trick so that I don't have to multiply both sides by 2 minus x and x minus 2, that I can just take and rewrite this and throw the negative up on the top. And now I have common denominators, see? Right? So when you see this thing kind of flip, reverse, that's when you're going to use that little trick. All right. But you're not violating any rules because of this. I'm going to look and see if I got any other good ones here that... I did ones like that. Oh, here, let's try one like this. Going back to some, we'll do an addition one. Okay, here we got it. This is a little simpler, but still kind of tricky. Plus, so like that. Okay. Yeah. So all we need to do here. Okay, again, I've been telling you, you know, you multiply this side by x squared. Well, you really don't have to, because this is just an x squared. So how can we get x squared over on that side? Yeah, just multiply by an x over an x. Okay. Again, if you just every time you do what that whole what do I got on this side, what do I have on that side, it'll work. It's just that it's going to cause you a little bit more work at the end. And I'm trying to save you that. So we distribute. 2x squared minus x plus 3 over x squared. Okay. And I know you guys won't, because you're smart and intelligent adults. But high school kids, they love to do that. Don't do that. You can't do that. Okay? They love to do that. They go over here and they go like this and they turn it in and I get mad and don't do that. Okay? That violates all kinds of algebra stuff. Alright? They love to do that. You might pre-calculus kids. Okay. What else can I show you? And then I'll let you do some stuff here. I think I covered most of the things. Here, let's do one like this, I guess. I'm picking all the kind of the harder ones. You can, but I don't think it's going to get you anywhere, because there's nothing on the bottom we're going to be able to reduce that with, right? Because you just got to square down there. No, you actually want to leave it in that form. The bottom is good to leave factors, but. I think I just... hang on a second here. This one I was looking at something different. Okay, so here's one with 3. Alright, but it's not really that bad. Okay, so, actually, I don't want to make you mad, but I want to throw that one. I want to do this next one instead. Sorry. Just cross it out or something. This is a much better one. Okay, let's look at this one. So now we have this, right? We got 1 over x minus 3, 2 over x plus 3, and an x squared minus 9 with an x on top. Right? So now we got 3 of them. My goodness. But what should I do to that last one? Could. I'm thinking of this guy, right? What should we do with that? Factor it, right? Okay, because look what happens when we factor it. Now we get this. Okay. And while I don't really want to multiply, again, if I understand fractions and how they work, I don't want to multiply this by this whole thing, right? And I don't want to multiply this by this whole thing. I really don't have to, because we have an x minus 3 and x plus 3 here. So what do we need here to make this work? No, and that's not going to really, that's going to give us a negative and a positive here, but we have x plus 3 there. Alright? So, well, yeah, let's just multiply by x plus 3, because this has an x plus 3, right? This has an x minus 3 and an x plus 3, so it's already got that. So all we need here is just an x plus 3, right? Because if we have an x plus 3, then look, it's going to be identical to that. The order doesn't matter because it's just multiplication. So if I multiply this by an x plus 3 and an x plus 3, okay, that one will be good. Now what about this middle one? What should we do with that one? We can multiply that one by an x minus 3. I'm just rewriting this, so I have a little bit more room. Okay, so let's multiply this by x minus 3 and x minus 3. And this one, I don't have to multiply by anything. Because look at those common denominators, just like that. Alright? So that's kind of cool. I mean, we don't have to, we factored this because we recognized there was a difference between squares. Right? And instead of making a complete mess out of it and ending up with all kinds of stuff, we just recognize, well, look, I have an x minus 3 and x plus 3. I have an x plus 3 here. All I need is an x minus 3 uncommon. All I need is an x plus 3 uncommon. So that's all I got to do. Well, we got to finish it, so we're going to distribute. So that's x plus 3, correct? Minus, so this is a minus, so it's going to go with that 2. So when you get a minus 2x and a plus 6 and a plus x, I don't have to do anything with this one at all. And the whole thing is over x plus 3, x minus 3. Now I just got to simplify a whole bunch of stuff. So what are we going to get on the top? So we get a 3 and a 6, that's 9. X is 2x minus 2x, gone. There it is. Okay, so that one there helped us to factor a little bit. But like I said, that was in the 80s, so I mean that's a long ways. The rest of them are going to be a little bit straightforward than that one is, but I wanted to show you one like that. So I tried to give you a little bit of everything, right? Ones where you had, going just kind of reviewing a little bit here. So here, we just multiply what was on each side, right? Which is never going to go wrong. It's just going to need you to some work at sometimes. And this one here is pretty simple. This has an x minus 1. This one doesn't. This has an x. This one doesn't. So I introduce that. Okay. Here, same thing. X plus 1, x minus 1. Here was that trick one where we had x minus 2 and 2 minus x. So again, see now in this case, this is what you want to look for, right? So we're just flipping that. Okay, so if I see x minus 2 and 2 minus x, x minus 1, 1 minus x, I know I can introduce that negative 1 there. Alright? Saves me some time. It's all about saving you guys time. And then one like this. And then finally. Okay? Whew. Questions on addition and subtraction then? Oh, no, it's okay. So, this 1x here, right? And this 1x here, we combine gives us 2. That 2x and this negative 2x, so that's going to go on. Leaves us with a 3 and a 6. Other good questions on adding, subtracting, anything? Okay, so I'm still kind of debating on 4-4, but anyway, I want to give you some time to work on these things, alright? Maybe a little more than I usually would, just because I want to make sure you got a good handle on them, because it's just, I threw a lot of stuff at you. And then we'll just kind of see what I want to do. So, yeah, go ahead and start. You take a break if you need to. I'm thinking maybe we'll 11 o'clock-ish or something. We'll stop, but go ahead and work on 250, 263, 274, and see how that goes. Okay? Make sure you follow the syllabus because there's a couple of people that are not. You're doing more problems. Don't do more problems. Okay, that's good. All right. Okay. So can I borrow yours? Thanks. Okay, so solving equations. Let's see. Oh, yeah, we got rid of those. Let's do it. All right. All right, so here's what we want to do here. So, we have basically the same thing we were doing before. Aaron said, so this is just an addition problem or a subtraction problem, but it's equal to a number. Okay, so that kind of changes things a little bit for us. All right, so the question is, well, what do we do on that? Well, the strategy that we want to use is to eliminate the bottom part of the fraction. So we want to take and get rid of everything that's on the bottom here. So we don't have fractions anymore. So we want to find kind of a common denominator, but not just for these two here, but including with that, so that when I multiply, it all goes away. So let's think about, we have a 2 there, 2x, a 4x, and a 3. All right, and somebody already told me, it was Karen, said 12, right? Okay. Okay, so we know 12 is going to be a good number for us, but we also have an x, right? So we're going to multiply by 12x. So that's kind of our common denominator. So now, and this is where I do this. I think this kind of thing is in 60, maybe? I don't remember. But it uses numbers. Okay, so if I take and go and aside here to each one of these, okay, here's kind of how we want to think of this. So we're going to take 12x times x plus 1. I'm really going to step this out a little bit. Okay, so write down what you feel like you want to write. All right. So I think that it's better that you think of this. So this 2 and this 12 is going to reduce. Okay? So when you're moving this 12 inside, the 2 and the 12 are going to reduce, and the x are going to reduce. Rather than actually multiplying it and then reducing, I think it's easier if you just get used to just reducing first. So 2 is going to go into the 12 and give us 6. And the x are going to go away. So basically, we're getting this. All right, now I'm stepping this out. Next time, the next couple of problems, probably not so much. But this 2 and this 12 reduce. The x and the x reduce. I have that. Okay, now the same thing's going to happen on this side. So the 4 and the 12 are going to reduce, and the x are going to reduce. And so that gives us 3. So now we would have 3 times x minus 1. And then on this one, of course, that's just going to give me a 4. So what's happened is that the bottom of the fractions, because we multiply by that common denominator, so to speak, is gone. The whole bottoms are gone.
But doesn't it need to be 4x?
Yeah.
Yeah, that's what, yeah.
So the bottoms are all gone. All right? And we don't have to worry. Now it's just a regular old algebraic simplified problem. So 6x plus 6 minus 3x plus 3 equals 4x. And then just grind it out. Okay? And that's the main idea. Now, I would probably write that many steps, okay? But we really want to just think about finding that common denominator, multiplying by that term, whatever that term is, and then reducing, reducing, and reducing. Make sure you multiply it to every single part, even the last one, because a lot of times it just goes to the first part, people forget to do the last one. All right, so you want to make sure you go all the way through. Okay, so let's take a look at this one. All right, so we're going to solve this. All right, now I probably want to factor this thing here. So we know that's a difference of 2 squares. So I'm going to multiply by this whole thing. Okay, so I'm going to take these inside, right? So now I want to think about this. So if I take this group inside here, this x minus 2 and this x minus 2, they're going to go away. Leaves me with that. Okay, same thing's going to happen over here with the 5. The x plus 2s this time, so I'm taking this again. This x plus 2 and this x plus 2 are going to go away. Leave me with the x minus 2. Equals. Now if I go to the 12, both of them are going to go away. And I'm just left with 12. So everything goes. And see, now it's so much simpler. Just that one little step makes it a way simpler problem. So now I just like it, now it's just like it's a regular solving problem. There we go. Okay, so we're multiplying by whatever's on the bottom, clearing that out, right? Things are going to cancel, and then it works out so nice. Let's see. They have some, I see some solve and check your result. I'm not too big on checking. You can check them by graphing them. I really don't know if it's something you want to do, you can. I don't think it's a, yeah, I think it's just, I don't know. It's going to add more time to what we can look at one. I'll show you why. It's a little cluttery. So that's why I'm kind of against doing it. All right. Let's see. Let's try another one here. This one's kind of different. Okay, so this one's like this. So it's equal to 0. All right. Here, notice that we don't have to worry about the common denominators because they're already there. They're already the same. But we can still clear them out. So if we multiply by x minus 1, what are we going to get over here on the left? So we're just going to get x squared minus 4x minus 5, because the x minus 1s are going to go. Right? They're gone. Plus, now I'm going here, now I'm going to go here. So what do I get right there in that part? 8, right? Now I'm going to go here. Well, what's that going to be? 0. Okay, so now I have this equal to 0, and the only way I can solve this is by factoring. At least that's the only way that the book thinks you know how to do it. Okay? Now, you're probably pretty happy with that. I mean, that worked out pretty well. However, one of these answers isn't any good. Because if we go back into here, what happens if we put 3 in there? Is 3 going to be okay? Well, what happens if we put 1 in there? So we have to toss one of those answers. Alright, so then this 1 is not any good to us. So every once in a while, you should kind of check to make sure that you're not getting a 0 down there. Because when you multiply by that x minus 1 or whatever's on the bottom, sometimes you introduce a solution that does not work. Okay? So be careful with that part. Let's see. I'm just trying to find. Let's do one where they want us to graph it. So we can kind of see what they look like. Maybe. Somehow I think it's not. Okay. I'll show you what it looks like graphically. So we're going to put this in here like this. Alright, so the 1/2 of it was, so I'm going to go y equals 1 divided by x plus 1 divided by, oops, careful here, 1 divided by x plus 1 divided by 2x. So that's part of it. Alright, so I'm going to put that in there. That's the left part of the equation. Then the right part is y equals 2x. So, where's our answers going to be at in reference to these two graphs? What are we looking for? These two things are equal, so we're looking where these two graphs do what? Intersect. Okay? There and there. So that's our answer. All right, now that's pretty simple in Desmos, but if all of a sudden I change this to 2 divided by an x, so I get this, or maybe I'll make it maybe more dramatic here, something like this, then it gets a little bit messier, and I got to figure out where they cross, and you can see where it can kind of get to be a mess. All right, that would be better. That would be there, and that's it. That's the only part they're going to cross at. And so when you put two rationals in, it's not that it's hard to do, it's just it gets a little cluttery, and I want to make sure. That's why I don't think you want to go about and check a whole bunch of them. You know, if you were doing a test or a quiz, you don't have very many. Maybe it'd be worth your time. You know, if you could sort out which one is which and know where they cross, it'd probably be okay. I'll let you guys make that call. All right. Let's see. We don't do any in the 73s through 86, do we? In the syllabus. Do I give you any of that on page 285? Good deal. I'll get this back to you. Is there anyone on there on that assignment on page 285 that you're looking at right now and say, I have no idea how I would do that? And look at your problems that you did.
Without actually looking at it, can we go through one of the word problems?
Yeah, which one do we have to do?
Let's do 88, and let's do 87 to 89.
Okay. You can just tell me what it is.
At a parking lot, the attendant can wait on 60 people per hour. If people arrive randomly at an average rate of X cars per hour, the average number of cars waiting to exit the lot is given by the function of n x equals x squared over 3600 minus 60. That's that as well.
So it's x squared minus 3600.
Yeah, that's what it's got.
Oh, got it. Oop. So it's x squared over 3600 minus 600? 60? X. Okay. And x represents the, what was that, the time? And n represented, what is it?
X is the number of cars per hour.
So x is cars.
N is the number of cars waiting to exit.
Okay. And what is it that we're exactly supposed to do with this thing?
So it says where x equals less than 60, the first part A is approximate x when n of x equals 8.
So when n of x is 8, so I'm going to make this 8, and I'm going to go like this. And I am not up on the board. Okay, so that's what I wrote. So it says n of x is 8, and I want to figure out what x is. So this is what I got. All right. Well, what should I do to solve that? Let's go like this. Cross multiply. See, you don't need to multiply that by anything because there's no adding and subtracting going on. So it's just straight up cross multiplying like you did in that one section, I think.
So this is a better way of thinking it. This would all, if this system is written.
Yeah, it's just a that's just a comma or something. Yeah, it's nothing. Okay, so now we're going to have x squared here. I need 8 times 3600. I don't know what that is. $28,800. Okay, and that should be good. So it's an x squared, so I got to move it over to this. I think I'll move these other things over actually. So I keep the x positive. And now I'd have to factor that. This is going to be fun. And they got to subtract, right? The 480. 400 is going to go in there. Ooh, man, that is close. Let's see. 836. 600 must go in there, I'm guessing. Does 600 go in there?
48.
Oh, rats. $500 go in there?
No.
I'm just trying to think of another one. It's got to be somewhere between, because this is subtracted to about 5 something, and the 4, this subtracts to 3 something. So it's got to be a number between 40.
What about 450?
Try it. It's got to be something between 400 and 600. And I might have it. 288 is 5. What's 288 doubled? 596? 576. Rats. I have it. Could graph it. Could graph it too, find out where the zeros are. That's probably quicker. So if you graph that in Desmos, it could be you're gonna have to play at the window, but we'll get an answer. I'd probably use the quadratic formula, but you know, you're not supposed to be able to use that at this point in time. But that's what I would probably do. It'd be so much easier. I'm typing it in and graphing it. I know you can't see it, but you can do the same thing. So there it is. It says it's 53.9. So they must have been expecting you to do something different there besides factor it. So 53.9, which would be about 54, because X is the number of cars. Obviously, you can't have 53.9 cars. So there's that. What was the other part of this? That's an A?
Interpret your answer.
Oh, 54 cars. So when we have 54 cars, then there are 8 waiting. Is that it? Okay. Yeah, I just graphed it and looked where it crossed at. So, all right.